Today we are continuing to solve and graph inequality word problems. So your essential question is, how do I solve and graph inequality word problems? Your learning intention, I am learning to solve and graph inequality word problems. You've got 2 warm-up questions. Please pause the video and see if you can do these questions on your own. I know that the first one you should be able to get pretty well done with. The second one might give you a little bit of trouble because it's x's squared. So if you don't get completely through the second one, please do as much as you can do. So pause the video and try to do the 2 equations now. Okay, I do hope you tried. If you try, the more you try, the more you think about it, the better you will learn. So on the first one, we've got to do that distributive property. It's got to go to both of them. 18 is equal to 3 times a is 3a plus 3 times 4 is 12. Okay, I've got both sides simplified. Now I'm ready to solve. To move 12 to the other side, I will subtract 12 from both sides. 12 minus 12 is 0. 18 minus 12 is 6. 6 is equal to 3a. What is my last step? To divide by 3. 2 is equal to a. When I put it in here, 2 plus 4 is 6. 6 times 3 is 18. That is the correct number. Okay, on the second one, did you get started? We've got to have the x squared by itself. What do we do first? Divided by 2 is the correct answer. X squared is equal to 128 divided by 2 is 64. Okay, now, what operation undoes squaring? X squared means that x times x is equal to 64. A number multiplied with itself is equal to 64. The opposite of squaring is square rooting. Now, if you've got your multiplication tables, if you notice, we've got that diagonal. That gives us our perfect squares clear up to 400. But I'm looking for 64. So when I go up, it's 8. When I go to the side, it's 8. 8 times 8 equals 64. So the square root of 64 is 8. 8 times 8 is 64. 64 times 2 is 128. So hopefully you were able to get that answer. If not, you learned something new today. So let's look at solving and graphing. This is the third warm-up problem. I think I told you you only had 2, but you do have 3. Okay, if nothing else, draw the lines for the distributive property. Did you do that? Okay, distribute the 3. Distribute a negative 2. 3 times x is 3x. 3 times positive 5 is 15. Negative 2 times x is negative 2x. Negative 2 times negative 10 is positive 20. Okay, take a minute and look. All we did is distribute. Now we're ready to solve. I look at my variables. I've got 3x, I've got negative 2x. Which one's smaller? Negative 2x. So I'm going to add 2x to both sides. It's gone. 3x plus 2x gives me 5x, plus 15 is greater than 20. Subtract 15 from both sides to get that 5x by itself. Five x is greater than 5. Divide both sides by 5. And x is greater than 1. So I put a 1 on my number line. Open or close circle? Well, it's an open circle, so I'll put a circle around it. Now, which way do I shade? Well, x is all the numbers because this is my smallest number. That's where the pointy end goes, to the small one. So this is my smallest, and I go to the positive side. So hopefully you were able to get most of it. Okay, write the inequality, solve, and graph. Angel goes to the amusement park. The cost to get in is $35. In addition, each ride costs $1.50. How many rides can he go on if he has $50 to spend? Highlight the important numbers. The cost to get in is $35. Each ride costs $1.50, and he has a total of $50 to spend. If all he has is $50, can he go over $50? No. Can he go under $50? Yeah, because then he can take money home. So 50. $50 is all he has to spend. It has to be greater than or equal to $35 is going to cost him to get in, plus $1.50 per ride. Any questions? This side has the total cost. This has how much money he can spend. So let's solve. Move the 35 over, so I will subtract 35 from both sides. $50 minus 35 is 15. 15 is greater than or equal to $1.50 times the number of rides. What do we do now? We will divide by $1.50. Now, I think I know the number of rides. Do you? If you struggle, that's okay. Grab the calculator. And we've got 15 divided by 1.50, and we end up with 10. So here's my 10 rides. It's a closed circle. The amount of rides I can go on is less than 10. 10 is my biggest number. So Angel can go on 10 or less rides. Okay, any questions? Okay, so Curtis spent at least 30 minutes playing his drums on Wednesday. He spent 20 minutes longer playing his drums on Wednesday than on Friday. How many minutes could Curtis have played his drum on Friday? So, if you're looking at it, he spent at least 30 minutes playing his drums on Wednesday. He spent 20 minutes longer playing the drums Wednesday than on Friday. How many minutes could he have played? So if we're looking at this, he spent at least 30 minutes playing his drums on Wednesday, but it's 20 minutes longer on Wednesday than on Friday. So the 30 minutes he was playing is 20 minutes longer, so I subtract 20, and that will be greater than x. 10 is greater than or equal to x, because they said at least. At least means we put that equal to in. So here's my 10. This time it's a closed circle. So he could have spent 10 minutes practicing. He could have spent more than 10 minutes practicing. So Curtis spent at least 10 minutes practicing. And that would be on Friday. So he could have spent more, we don't know, but we know that he played 30 minutes longer on Wednesday. 20 minutes longer on Wednesday. So it could have been more than 10, and then it would have been more than 30 minutes he was playing, but it would not have been less than because of the at least. Okay. I've got a garden. In my garden, I've got tomato plants and zucchini plants. My garden has at least 75 plants. And my garden contains 32 more tomato plants than zucchini plants. So my garden has at least 75 tomato plants. Write an inequality to find the possible number of zucchini plants that are planted. So if we use Z for zucchini, so I've got 32 more tomato plants than zucchini plants. I have at least 75 tomato plants. So to write my equation, how would I start? Okay, so it would be 75. At least means greater than or equal to. Okay, so I've got 32 more tomato plants than zucchini. So that would be my zucchini plant plus the 32 more tomato plants. Now, we're going to solve. We will subtract 32 from both sides. 75 minus 32 gives me 43. It's greater than or equal to the number of zucchini plants. So, I have at least 43 zucchini plants. So if you're looking at this, your zucchini plus 32 has to be the number of zucchini plants to get it up to 75. So if you're looking at this, all you have to do is subtract 32 and you're done. Okay, so let's look at the inequality that is graphed. It starts here and goes this way. Okay, so if you notice, everything is smaller than this number here. So x is less than, is it equal to? Yes, because it's a closed circle. The number between 10 and 12 is 11, and we're done. For this one, we've got, it starts here at 3, but is it equal to 3? No. So 3 is less than x. Okay, now, which inequality is the one that you see in the graph? What do you notice about all of these? Well, number one, we'd probably divide by 2. But let's see which ones are not acceptable. So we kind of save ourselves some work then. Okay, as I'm looking, this is a greater than statement. Or less, if you're looking at 4, 4 is the smaller number. So I'm looking for something that is less than. So it could be one of these two. This one doesn't work at all because of the fact that two numbers cannot, negative 8 is not greater than 16. And in this case, this is greater than, so it will not work. So now I'm going to simplify. Well, do I even have to do that? I've got an open circle. Which one shows an open circle? The open circle is simply less than, and we're done. So think it out. That type of problem you can think about. If I wanted to check, I would have negative 8 is less than 2y. Divide both sides by 2. And negative 4 is less than y. And I'm done. So how do you know when you're successful? You know you're successful when you can solve and graph inequality word problems. I need to put a y there instead, IES. And specifically solve graph.